Okay, so today we're going to talk about radian and degree measure. Okay, so there are two ways to measure angles, and they are in radians and degrees. Traditionally, you would see, an angle um, listed like this, and you would have, your angle. Let's say this is 45 degrees. Okay, well, that's because a circle, or an entire circle, is made up of how many degrees? 360, right? And so if we were to break that down into a 45, that would be a small slice of that. So something like this, right? That's like a 45-degree angle. But that's degree measures. It's all based on a circle. Well, radian measure is kind of the same thing, except we measure, instead of 360, it is 2 pi. Now, the reasoning for this is that 1 radian is equal to a sector of a circle, or the measure of a circle that has a radius from the center, and then that same radius wrapped around the outside, so that distance is also r, and then this distance is also r. So you've got kind of this like equilateral pi type shape, but the angle inside here is 1 radian. Now, if you notice this, the circumference of a circle is 2 pi r. Well, so that would make sense why this ends up being 2 pi. That comes right from there. So it's all about the distance around the circle. And that's why we have 2 pi radians. Okay. Now we're going to talk about how we're going to talk about some things about how we measure angles in radians and how we measure angles when we're talking about circles. And mainly, it's not necessarily about a circle, it's about rotations, things that continuously rotate or periodically come back to the same points. So with that, we will bring in an idea of initial and terminal rays. Or sides. You might see this listed as sides. This also brings an idea of something called a coterminal angle, and we'll explain what that is in a minute. Okay, so the way we measure in trig is different than geometry that was just kind of fixed shapes. We can have angles, positive, negative, all the way up to infinity if we wish. When we start out, there's a starting point, which is called an initial ray or an initial side. We're then going to have what's called a terminal side, or a terminal ray. Now, what's really basically happened is this is fixed. Okay, we started there and we've ended up at this endpoint. So we've rotated our ray up, and this is what our angle measure is. This little curve guy right here. Now we'll call this guy 45 degrees. That's about right. Okay, so this is a 45-degree angle measure. And it's all based on going from the initial to the terminal. Now we could do the same thing going backwards if we wished. We could go backwards 45. And we'll call this terminal ray number 1, and we'll call this terminal number 2. Well, if we go counterclockwise, it is a positive angle. If we go clockwise, what would it be? It's going to be negative. So we get a negative 45 degrees. So we can have a negative angle. That's okay. It just depends on the way that we are rotating from the original position. Okay, so 45 is if we go counterclockwise, and negative 45 if it's the same amount of rotation, but only backwards, right? Only if we go clockwise, which is interesting. So just realize that negative angles are just us counting backwards or going clockwise. Now, because of these rotations can go on and on and on, there's this idea of what's called a coterminal, which now that you know what a terminal ray is, it's a coterminal is going to be two angles that have the same initial and terminal sides. So let's look at this. So let's say we've got this angle here. We'll pick on 45 again. So 45 degrees. So we've got our terminal side, our terminal ray, and we've got our initial ray. Okay, well, a coterminal just has to share both of these things, right? Well, one cool thing that we can do is just continue to rotate. We continue to rotate our ray around until it gets to this exact same point. So if we think about our terminal ray as a starting point now, and we want to make it all the way back, what shape do we make? It's a circle, right? And how many degrees are in a circle? 360, right? So we add 360 degrees to our angle. Funny enough how that works, right? So 45 plus 360 gives us 405 degrees. 405 and 45 are coterminals for each other because they're 360 degrees apart. That's how that works. We could also go backwards if we want. Again, we're still going to have the same initial, we're still going to have the same terminal, but we want to have maybe a different angle. Well, what if I wanted to count backwards now? So I go here and I'm like, oh, I want to go, wrong way. I want to count backwards. Remember, we just learned that this would mean a negative. So we've lost 360 degrees. Well, what if I take 45 degrees and take 360 away? How many do I have? Well, this is going to be negative 315 degrees now. Okay, so we've gone backwards that many. Well, that's fine. These are both coterminals. Guess what? 45, 405, and negative 315 are all coterminal angles of each other. And this is important because they share many of the same properties that'll be useful to us later. All right. Lastly, we're going to talk about how to convert between radian and degree measure because they are both used. Well, as we said before, we have 360 degrees and we have 2 pi as being a full circle in both realms. Well, if we want to equate them to each other, 360 and 2 pi, what we do in trig is we kind of isolate pi. We use that to solve. So if we divided both sides by 2, we end up that pi is 180 degrees. Okay, so that's how we actually we convert between the two. Pi and 180 are the same. So if I were to go from radians to degrees, okay, so I'm starting out with radians. I'm going to have my radian measure. And what I'm going to do is I'm going to multiply. So I'm going to try to get rid of the radians. So I'm going to multiply by the degrees, and I'm going to divide out the radians. Remember, this is equivalent to each other in our system when we're converting between them. So if you're trying to get rid of radians, you divide by pi, which is the radian form of 180 degrees. And so you convert it into degrees. Conversely, if I wanted to go from degrees to radians, I start with my degrees, and I'm going to multiply by my radians and divide out degrees. Okay, so it's kind of the same idea. So with this one, I want to get rid of the degrees and add the radian measure in and divide out these degrees. Okay, so you can do this for any amount of radian and degrees, and check out the example problems video for some more examples.